Today I want to talk about river processes, otherwise known as fluvial processes, and how about these processes in the river change the course of the river and help create landforms along the course of the river from source to mouth. As we've just seen in this, rivers don't stay still, they change their course, they change the path they go under, and that's largely because of the processes in the river. So to help you remember these river processes in an easy way, I've come up with this device, and it all revolves around this guy who was a German tennis player called Tommy Haas, who you can see in the picture. And you don't need to know anything else about him apart from his name, and his initials are H-A-A-S. And I'll explain to you in the next couple of pictures how we can remember all the processes of river erosion through Tommy Haas's name. So the first river process to remember is hydraulic action. So in Tommy Haas, that is the H. This is where the force of the water hits the riverbank and the riverbed, and it's the force of the water that is actually dislodging the material. So it's the force of all the pressure of that water hitting the sides of the riverbed and the banks and dislodging the material, which then is carried away down the river. The next process is called abrasion. So this is where the material that's being carried, what we call the load, as it's carried along the river, this will again hit the river banks and it will hit the riverbed. And as it does this, it kind of scrapes away, it rubs away the sides of the bank and the riverbed in a kind of sandpapery action. And this makes the river wider and deeper. So abrasion is the load that is being carried, those rocks rubbing against the banks and the bed in a sandpaper action and dislodging material. The next day we have is called attrition, and this is where boulders that are in the river, they actually collide with each other. And what this does is that it basically breaks these rocks down into smaller rocks first of all, but it makes the rocks more rounded. So as we go further down the river, you'll find that the load material, the actual boulders and sand and rocks that are in the river, they will get more rounded because this process of attrition is happening. This is one of the processes does not erode the river channel, so it's not making it wider or deeper. It's just it has an effect on the actual load of the river. The last one of the river processes to know is solution, and so this completes our Haas. And this is where minerals in the rock on the riverbed and on the riverside are actually dissolved as the water passes by. So it's to do with the chemical composition of the water and the rocks, and so that the minerals in the sides of the river are actually dissolved away. Once all that material has been eroded, we need to know how it's transported down the river, and there are 4 different types. The largest boulders are moved through this process called traction. And I was trying to think of this a bit like a big tractor wheel. It takes a lot of energy to move it, and so they won't be hopping up and down. It just rolls slowly along the riverbed. When we've got slightly smaller material, pebbles and silts, it actually hops. And I always again think of it a bit like pouring salt onto a table. Some of it would just fall on the table, but then some of it would just hop up and down. After that, we've got suspension, and this is finer material that is not just hopping anymore. It's fine enough that it can actually float in the river, and that's suspension. And I always again think of this a bit like one of those suspension bridges that is suspending the material, in the way you suspend a bridge. you're suspending it off the ground in the same way that this material here, which is light enough to be suspended. And the last one is solution. Similar to what we had in the erosion, it's a similar term, and it's that dissolved minerals, or that stuff that's been dissolved from the bank side, that is just floating in the river, but you can't see it. It's what we call soluble material. Okay, so how you remember those four erosional processes? I've got this little nifty hand trick that I think works quite well. So for the H, the hydraulic action, imagine it's the force of the water hitting you in the chest. So you can just do that chest pumping motion, a bit like Wolf of Wall Street, if you've seen that one. For abrasion, remember it's a sandpaper motion. So if you do this, you rub it on your arm, you feel the friction, that's the sandpaper motion wearing down the riverbed and the riverbanks. Then the attrition, it's boulders colliding into each other, so your fists hitting each other. And the last one, solution, probably the hardest to remember, but imagine you're just pouring some like acidic solution. So you're pouring solution and then it trickles down. Pouring the solution and then trickles down. So pumping the chest, hydraulic action, abrasion, sandpaper, attrition, boulders hitting each other, and then pouring the solution down.